This is the Amp Hour Podcast, recorded August 26th, 2012. Episode 110, Outstanding Oneirophoros Obituaries.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of ChipReport.tv.
ChipReport.tv, huh? You're up to episode number 3.
I am, yeah. This last one was a doozy. I'm actually starting to loosen up a little bit.
I saw it. Yeah,
you did?
And you even told us about it.
Yeah.
I'm starting to loosen up.
Yeah, I'm trying, yeah. You see my Buck Fitty thing?
What?
Buck Fitty? That was my little fun editing thing.
Gesundheit, no? I have no idea what we're talking about. Zoom.
Check out like about 5 or 6 minutes in.
Oh, right. No, sorry, I didn't get that far.
Yeah,
right.
Okay.
Yeah, fail. No, my attention span's not that long.
Yeah.
Sorry, dude.
That's okay.
Man,
yeah.
Neil Armstrong died.
He did. He's not the only one.
Oh.
We lost a couple big ones this week.
Who?
Or last week, too. Well, Hans Commonsend also passed away.
Course, yeah. Oh, yeah, we didn't...
Remember, we're 2 weeks out.
We didn't report that because we had a guest last week. Yep.
Right. Yep.
Very sad.
Two big engineering heroes are gone.
Because if people don't know, Neil Armstrong was an engineer, as were all of the original Mercury 7 and Apollo astronauts. Right. So were all engineers. So you had to have a degree in some form of engineering to get into the space program back then. Right.
And he was also a test pilot.
And he was also a test pilot, of course. That was the other requirement. You had to be a test pilot, you had to be an engineer, you know.
Right.
Because
well, at least to be the pilot, right? Did you have to be a test pilot even if you weren't?
All of the original Mercury 7 were all test pilots, but the others weren't. Like Harrison Schmitt, of course, got in because he was a geologist. I think most of the others were, though.
Okay.
But yeah, it's... Yeah, they were all test pilots / engineers who went to the moon. Yes.
Badass geeks right there.
That's it.
Yeah.
And they actually had pocket protectors back then.
Oh, yeah, big time.
Oh, I love it. That was sad.
It was.
And, of course, Obama comes out. I'm going to have a whinge.
Of course you are.
Oh, man, he comes out. You know, I actually tweeted this. This is what he'll come out with, you know. And, come out, rah, the spirit of adventure's not lost, and it's still, spirit of adventure is still with us. Bullshit it is. How about funding the bloody thing for a start?
Yeah.
You know?
Yeah, man, I'd like to see that too, but...
Yeah, dickhead.
We gotta stick with robotics for now. Yeah, well, politics. Yeah.
No. Unbelievable. And
there's a piece of subtext on the XKCD comic about how many people are left on the moon and the actuarial tables about how long they live, and it says something like there's a range of planets throughout the universe who, due to economic conditions, decided to not explore any further than their own planet, right. Or something like that.
Nice.
Yeah.
Yeah, that's pretty much what it is.
Right.
And I tweeted. I did the math. You can put, I think it was 250 tons of people or shit or whatever it is on the moon for every year for the cost of the US's maintaining their nukes. Go figure. It's expensive, but it's considering what you piss the rest of the money away on. It's Yep.
Yeah, it's too bad. I've always said that if just like the original space program, if things ever get kind of dicey with the U.S. and China, like in the Cold War kind of starts back up with China, of course, instead of Russia, it's like that's kind of sadly the greatest hope for a bigger space program is China saying we're going to Mars, and someone else saying we're going first.
Yeah, that's right, another space race. And I've seen lots of space videos recently with all the the Mars Curiosity stuff.
Right.
So, I've been watching many hours of space videos on YouTube, but I can't remember who said it. Someone will correct me. I'm sure. Maybe many people have. A few people have said it, but the kids have lost they have nothing to dream about anymore. If you want to be an engineer, somebody said, I can't sell to a kid, look, become an engineer and you can eke out a 10% efficiency in this rocket motor, right? That's not going to get a kid excited and involved, but hey, you can design this rocket which lands on Mars, that is, right, that's what's going to get the kids in.
Yeah.
To engineering and science and everything else, right?
Yeah, it's tough. It's I saw there's this great quote actually. It was I forget who it was. I think he's what was he? He founded a new big data company, and I forget the guy's name though. It was a interview on Business Insider, and it said, "A great tragedy is that the best minds of my generation are trying to get people to click more banner ads." Yeah. And it's true. I mean, like
I know it's very true.
It's sad, but I don't disparage it quite as much. I mean, you're a little older than I am. I mean, you got a little more cantankerousness in you, right?
Exactly.
And that's to be expected. I mean, but I think there is a lot of exciting stuff going on. I mean, hey, the curiosity, right? That alone. I mean, yeah, maybe you're not going to set foot yourself, but maybe you can control the robot that's blasting shit away with lasers.
And that's what's going to get kids in. But it needs big, pie in the sky projects like that to do it.
I don't disagree in the least. I think that kind of stuff is very necessary. I think you're totally right about that.
Yep.
But that's why the amp hour is here. Come on, Dave. We'll inspire for big projects. Big. We got big projects, right? You too can be a podcaster someday, kids.
Yeah, exactly. You too can eke out a full-time living from being a video blogger. Yay!
Yes. Someday you can be a cranky Aussie. Repeat after me. G'day, mate.
Oh, man, that's bad.
Yeah, it was, right?
It's not as bad as my American, so...
Yeah, right?
Oh, boy. Yeah.
Yeah.
Oh, the kids are just salivating at the thought of getting into our profession now, aren't they?
Oh, yeah. Big time.
Boy. Oh. Anyway, I think it's tragic. Neil Armstrong, one of the true adventurers.
Yeah.
Yep.
Well, what about Hans, though? Hans is, Hans passed away, too.
An adventurer of analog.
That's right, exactly.
In the analog domain.
Yep, 555s. Will live on forever, though,
Did you hear what happened?
I'm sorry?
Did you hear what happened?
Like how he passed away?
Yeah, because I don't think like he wasn't like 100, he was...
No, he was 78. It's an article in the E-Times just said he passed away in his sleep. I mean, okay. I'm not sure if there was health problems or anything, but...
Right.
I finally got the 555 contest back online.
Right. I didn't know it was down. Sorry, I visit it every day, clearly.
Oh, I know, right? Yeah, it's a pretty regular location for a lot of people.
Why is that? Is it just it just got up in the Google rankings or what?
No, I'm kidding. No one ever goes there.
Right. Okay.
When he passed away, I was trying to
I
put
thought
up.
It might have been,
No. I mean, I was just trying to put a tribute to him, and
right.
And yeah.
And even you had forgot your own site was down, right?
No, it was. I actually went to go update it and it broke.
Right. You broke it.
I have a theory that anything I do online is like poison. I mean, I can kill just about any server, and yeah. So I unfortunately brought that down when I was trying to put up a tribute. Yeah, but
nice work.
Yeah.
Oh boy.
Yeah. So there's one up there now though, and it's sad. It's he actually wrote an interesting book though. I didn't realize this. He put up.
Yeah, I haven't read it yet. You can download it.
No, not that one. Not the designing analog circuits. The he did write one about designing analog circuits, and I think that's the one you're talking about, right?
Yeah. Yes, I am.
Yeah, so you can download that. He actually wrote a history book about forgotten minds or forgotten people in electronics.
Yes.
Yeah. So he wrote about Tesla, and he wrote about a bunch of other people. I haven't read it yet either.
Neither
but,
have
I mean, I might have to pick this up. It's an interesting idea. Yeah, it's like small things throughout history that really affected a lot of stuff. I mean, him. The irony there being that him being one of them, right? I mean,
right? Yeah.
If people don't know, he actually not only did the 555 timer, but he actually put the first. He integrated the first Class D amplifier on chip. I mean, it existed previously. He did not invent the Class D, but he one of the first controllers he put on chip, and that's pretty cool too. I mean,
and all the purists out there booing.
Oh, all the Class A audio
the Class
files.
A audio files, yeah.
Right.
Yeah.
I need to burn at least half my power in order for it to be good.
That's it, yeah.
Yeah. No L's and C's in my circuit. Yeah.
Or if they are, they're gold-plated.
Really. Yeah.
And hand-wound by nude virgins, yeah.
Yes. Oh, yes.
Ah, boy. Everyone keeps asking me to do another rant on audiophile stuff. There's a big thread on the forum. There's just so much snake oil shit out there. It's just... You can't possibly keep up.
No,
Man.
You can. Yeah, it's not worth it. Come on, it's like, do you want to yell? I mean, like, do you go down to find the mentally disturbed bum on the street and shout back at him? It's like, well, no. I mean, you could.
Right.
Eventually, though, you become the crazy person. So
yeah, exactly. And some of these people have deep pockets, and they have no problem suing. They are not of these people are not of sound mind. Okay, they are not of reasonable mind. They will sue your ass to protect their little scam. You have to be careful dealing with these people, especially the big players. They will, the small players they're not too much to worry about. But yeah, the biggies, absolutely.
Yeah, well, I don't know.
But I'm not one to back down. I'm not one to be scared of shit like that anyway. But
you're just not wasting your time. That's just silliness.
I'm like
I think.
number 1 or number 2 on Google if you type in audiophile. Or, sorry, not Google. YouTube if you type in audiophile, woohoo! Number 2 with a bullet. So, yeah. Pisses a lot of people off that I'm up there, I'm sure.
Yeah.
Well.
Speaking of wasting time, we... not only did I waste time in all of the time I spent working on the discussion server, the discuss.theamphour.com, that is now dead and gone.
Well done.
Yeah, thanks. We actually moved our link board over to Reddit, which Dave hates. But if you go to reddit.com/r/theamphour, you can see all of our links that we're talking about this week and next week, and kind of a running list, and you can comment on them and everything.
And you can upvote them. Not that we'll talk to them, not that we'll talk about them because they got upvoted. But maybe we should. Right. I should promote that, right? That's the idea. If people upvote it, then we guarantee we'll talk about it. I don't know.
Sure, yeah, maybe.
Because this is an off-the-cuff show, This is just a...
Yeah, I don't know. I wasn't doing it by that, but it's just kind of a place to put links. But what I was getting to is a great way to waste time. You can see all of our links before the show even happens, and then you can comment on it. And yeah, that's a great way to waste time.
As if there weren't already enough ways to waste time on the internet.
Yeah, that's right. Twitter, folks. Sign up today.
Oh, boy. I swear I'm going to have to switch my computer off for X number of hours a day. Or switch my modem off at least.
Switch your brain off.
I can't do that. That's not possible.
No, it's not. But maybe once the human brain is modeled, we could turn it off like that, right? You put a link on there about that. There
is a great article in this month's IEEE magazine, which we like. We both get and we like. The Spinnaker chipset. Spelt exactly the same way as in the boat Spinnaker, the sail that goes out the front that catches all the wind and all that sort of stuff. I'm not sure what it stands for.
I thought that's the jib. Isn't the jib up front?
Oh, I don't know.
Maybe it's another part of it. I only know a little bit about sailing. I've never
I know.
owned a boat. I've only been out once or twice. So, okay. Anyway, Spinnaker, yes.
Yes, Spinnaker. No, I'm sure the Spinnaker is the big one out the front to catch the... They put it up when they want to catch the wind and go full speed downwind. I could be wrong.
Cool. I don't know.
Do not take financial advice or sailing advice from engineers, folks.
Until they're very successful, of course, right? Once you've made it, then you have probably boats and lots of money to dole out the advice along with, right?
Oh, boy. Yes, a boat is a hole to pour money into.
Oh, yeah. So let's hear about the Spinnaker chip. It's a chip, right? Now, you wrote about multiple chips. Now, is it on silicon or what?
Well, yeah, the Spinnaker is a chip. They started in what was it? In 2005 they started out this, so it's been going for quite some time. They got $8 million in funding from a UK government grant thingo. So good to see the money
Okay.
actually, spending the money on something useful. And to model the human brain. So they developed this chip, and this chip has how many? It's got 18. Where is it? Yes, 18 ARM 9 cores. Okay, that's a good thing about the ARM because you buy the IP and you can just drop it in, right? So they used ARM 9 probably because, well, it's easy the tools are easily available.
I'm guessing probably when they bought it, they probably bought it a couple years ago, and that was probably
yeah, exactly. They were sort of
takes a while
locked
to
in.
get integrated.
Yeah,
So.
yeah. It must have taken many years to actually design this chip and then get it made, and so it's not like you can suddenly change late in the design cycle. Oh, we'll use the latest ARM core.
Right.
No,
Let's do everything over.
Yeah, exactly. So you have to lock it in a long time ago because it wouldn't have been a big group. I'm sure it was a smallish group. Anyway, it's got 18 ARM 9 cores on it, each with its own local RAM and routing, and it's got like a big routing core in the middle of the chip. You can go, there'll be a link on the site. You can go check out the internal structure of the chip. And then it's got SD-RAM controller, so each chip has 128 meg of SD-RAM stacked on the chip. I'm not sure if it's stacked on die or whether or not... well, I think it probably is, actually. Because I don't see anything on the board.
I think so, yeah.
So it must be, the SD-RAM.
Yeah, so they do like flip chip or something.
Yeah, they
kind of
do
similar
flip chip or
technology.
something. Anyway, it's all packaged in this one Spinnaker chip, and then they
put down a crap load of them.
and then they put 48 of these chips per board. So what's 48 times 18, right? So that's how many processors you've got per board, and then the entire system that models the brain or a part of the synapse part of the brain. I don't know. Right.
Yeah.
Don't take brain advice either from engineers.
Yeah. Especially not electrical engineers, maybe
Exactly.
like biomedical, right?
Biomedical, yeah. Anyway, a total of 57,600 chips. So, hang on.
Unbelievable.
Calculator. Where we go?
Yeah.
We're talking
Yeah.
57,000.
Was it HP 15 you got there? You got your...
No, I've got a
Old
Casio
school.
FX 992S, which uses a ridiculous VPAM system. I hate VPAM, but it's the one I've got to hand.
no
here.
idea what
I
that
think the
means.
other one's visually perfect algebraic model.
Sure.
Yeah. Anyway, times 57,600 times 48. No,
Why are you saying
18?
48? I don't get that. It's 18. Yeah,
Hang on.
57,000 times 18.
Yeah, there's over 1 million. There's 1,036,000 cores
Whew, that's
in
a lot.
this system,
Yeah.
but it's not much. When you're modelling the human brain, it's you can only model like a couple of neurons or a couple of synapses or something. I don't know. Which is the amazing part of the brain. It just models one little tiny node, and scary.
Yeah, that's crazy, man.
I know, but it's awesome. This type of engineering, I love it. It's great. I just love these big boards that have 50 big, huge chips on them.
All I can think is like they're gonna end up on eBay someday. Like
Right.
like you or Mike's Electric Stuff are gonna get one of these and just be like, because
Right.
like eventually
Yeah.
they will. I mean, like they're so incredibly specific, right?
Yeah, exactly.
And this being versus like a lot of supercomputers actually use FPGAs these days, and I think these still have FPGAs on the board. If I'm looking at it right, I think they still route some signals
Yes,
with it.
yeah,
but
yeah, definitely.
but still, I mean, like that's a lot of good gravy. I mean, like that's a lot of stuff, right? I mean, like
Yeah, but you can't reuse these boards. They're like, because they're purpose designed. It's
Right,
not like
exactly.
you can hack them to do something. Well, you probably could, but by the time you figured out how to do it, it'd be...
well, what did you need all this
it'd be useless.
juice for, too,
Yeah,
right?
exactly.
I mean, like,
I don't know.
Did they say what the eventual goal was? I mean, like, I didn't get a chance to read this whole article. Did they say they want to put someone's brain in there? I mean, are we going to have...
No, they just model in certain parts of the brain, and it's ongoing research. There's actually quite a few groups actually trying to do this. So
Okay.
it isn't just one group.
That's good.
Yeah, I'm not sure what the ultimate goal is, but it's to figure out, because they still don't know how the brain works. So that's why it's like a development platform to figure out how the brain works. To see if they can develop the algorithms that work similar to a brain. It's not like somebody's already figured out and, if we just put enough chips, it'll work exactly like the brain. No,
Right.
they still have no idea how the brain works. Well, they have some, but they need these, it's a test bed. It's a hardware test bed to model all their algorithms and, try and come up with something that works very similar. So,
Well, that's pretty cool. That's pretty cool.
I like it.
Yeah, and they're not the only ones actually looking into this kind of stuff. The Wired had an article this week actually about analog processors. I don't know if you saw that.
No, they're making a comeback, are they? Analog processors?
Well,
Didn't they go out in the 60s?
I think it's all theoretical still. I mean, it's a DARPA thing, but it's the idea is that eventually you're going to run into power and speed limitations and size, right? And so eventually you just move to a different topology. I mean, you stop doing binary logic, you start moving to tertiary logic, and then eventually you can keep moving your way up. And
yeah, but then you get to a point where yes, it is like it's analog, but then you can't. There's a reason why we went to digital. Away from analog is because it's predictable. Right.
Right. Yeah. I mean, it's less. It has less noise problems. But I mean, you think
exactly.
But they also talk about probabilistic computing, basically. Basically
99.9% of your bits will get there.
Yeah, you don't. Well, that's the idea.
On
is that
average,
basically you don't need to do it. You don't need to get all the information all the time, especially at high speeds. That is the idea.
Right. Yeah.
And I mean, this is all very early stuff. I mean, this is still in. They don't even have chips yet. I don't think so. It's,
right.
But they're looking into it, and that's kind of cool. And I've said that for a long time too. I mean, like you think about where it can go. There's only so many knobs you can tweak, and eventually you're gonna. We're running out of the space one, right? I mean, and even who did we talk to about that? Was it Oyvind who we talked to? I mean, basically, even when you keep shrinking transistors, maybe it was Steve Liebson, I don't remember who it was, but as you keep shrinking transistors, you run into a whole lot of other problems. I mean, they're already running into some of those at 28 nanometers, which is what the current node they're at. Next is 20, and then 14, and then 10. The problem, it's still very tough because as soon as your transistors start getting smaller, then your leakages go way up, so your power starts, going way up too, and it's just there's a whole range of problems, and then there's the whole running out of atoms. Eventually, you're going to just be, you have to say one atom on, one atom off, one atom on, one atom off, and
but then you can go in other dimensions. You go the other dimension. You go instead of 2D, you go 3D, right? And it's there's ways around that. There's physical ways around that.
Yeah, but that's still all predicated on a smaller gate size and everything else, right? That's been what Moore's law is built on, is a smaller gate size. And I have no doubt in my mind that they'll continue to innovate on that stuff, right? But it's eventually they're gonna not run out of.
Yeah. I mean, there is a physical barrier.
Oh, yeah. But I mean, it's not going to be a running out of room or running out of options thing. I think it's going to be a running out of economic decisions that make sense after a certain point, right? I mean, if it takes you,
of course,
if it takes you if it takes a 50 billion fab instead of a 10 billion fab as it is these days, right?
That's
then
right.
eventually you run into some kind of problem. I mean, you're still going to be making the analog stuff at 90 nanometers or whatever, but
the industry's self-regulating. Kind of in that way, there's only so much people will pay for a chip, and there's only so much the investors will pay, and there's only so much,
Yep.
So and whoever comes up with the cleverest idea at the lowest cost will win.
Yep, definitely.
That's what it comes down to.
And it's become such a big economic argument too. It really is like it kind of sucks because it's like electronics running into economics, and that's. Kind of not outside the scope of the show, but outside the interesting factor, right? It kind of gets kind of boring, and we know that sourcing and part what's it called, like buying parts and everything. That's all still really important, and but it's just kind of boring sometimes.
Well, yeah, but that's what engineering's all about. Engineering ain't landing shit on the moon all the time. It ain't landing shit on Mars.
Yeah, that's right. Right, it's not always sitting in the control room with a mohawk, right? It's sometimes also sitting at your computer working through MATLAB simulations and punching your keyboard, right?
Have you seen the video that they did where NASA and we know it? Where NASA
that was lame. Yeah.
Yeah, but it was kind of funny.
Yeah.
I thought it was pretty funny.
Yeah, well, we'll of course now put it in the show notes, and everybody can see it.
I'm easily amused, though.
Yeah, that's fine. It's The musician in me was just like, oh, come
No,
on, you didn't sync up the lyrics to the music. Come
I
on,
know.
you
See,
know?
I know jack shit about that, so that's why I enjoyed it. You know.
Yeah. See, once you get past that, it is a lot of fun.
Right.
Speaking on the fab side of things, there's actually talk now of Apple buying into fabs and maybe having... So basically, Morris Chang, the guy from TSMC, mentioned the possibility of Apple having their very own fab.
Wow.
Right? That's how big they are. I mean, so people don't know.
Well, they've crunched the numbers, right?
Right,
and they've gone, it's going to be cheaper. Because they've got like $50 billion cash in the bank or something, right?
Yeah, they did. I think they probably still do, right? I mean, I don't remember.
I'm sure they do. I think they just had record profits or something, you know. So I know it's just, of course they can. You know, they can do that with petty change. You know.
Yeah, I mean, and they do that already, right? They come to a fab and they say, we want to buy your entire output. You know, all of the wafers in a month, and so I mean, I guess it does kind of go from there, but I don't understand the whole, like, so now they're talking about insourcing, right? Where Apple is actually in control of the fab and everything like that too. I don't think that's going to happen. I think that's a load of crap, to be honest. I don't think that's like the difference between being like, hey buddy, do you want to have like 4 girlfriends and you know, you can just kind of imply what you want to all of them, or do you want to, you know, marry one of them and and you know, and be tied to the fate of that? No, don't get me wrong, I'm married and I'm getting myself in trouble here. But basically that's the idea, is right. I mean, they'd be tying themselves, you know, to that fab. So if something went wrong, they couldn't just be like, all right, well, we're going somewhere else, you know. So that's the difference. Yeah.
You wonder how
I don't think it's going to happen.
You wonder what pisses me off. Apple just won their patent lawsuit against Samsung.
I know.
It just happened, yesterday or something?
Yeah.
And now they're talking about, the Samsung phone may be banned in certain countries. As their tablet was here. I mean, they couldn't sell their tablet here in Australia while a court case was pending. They finally won it for their Tab notebook or whatever it is.
Yeah.
But, man, it just pisses me off.
I know. It's a lot of lawyer shit, right? I mean, there's a reason Apple has a lot of money. But, man, yeah, it was just you know what's annoying to me about all that? It just flooded the news stream, right? It was just like you couldn't get away from it.
Exactly.
And it's like, I don't give a crap what, you know, like, oh, well, your UI has this button that's just like our UI that has that button. It's like, who cares?
I know.
Get out of my face. I don't want to hear this stuff. I just want to get past it and hear about... I want to, you know, if they're talking about new stuff, I don't know. My hope is that it's a window for some smaller player to come in and, you know, eat their lunch, but I don't know if that's going to happen. It's just such a big game these days that it's a mess, right? It's like there's...
And we're sick of hearing about it.
Yeah. It's...
Gee, well, you know. Did you hear that Microsoft were going to make like 3 million of their glass tablet things?
The Surface?
Yeah, Surface or whatever it is. Yeah, something like that. Even though nobody's actually used one yet, apparently.
See,
it's
that's
kind
the thing.
of like a vaporware, and they've suddenly announced that they're going to make 3 million of them or something. It's just
so weird how all these software companies are making hardware. It's just because they all have so much, you know, software has so much money, right? I mean, like, they have
Valve.
tons of money, right? Yeah. Hey,
Hello,
Valve,
all our friends at Valve.
Yeah. Right. It's the same thing, right?
Yeah.
It's just they have money, and now there's an economic reason for them to be making hardware, and it's like, well, hope they hire some good hardware people like Valve did.
Exactly. Valve may not necessarily manufacture their hardware,
right?
But yeah, they're doing it for the R&D side of things, and they feel as though they have to.
Yeah,
it's an area that they have to at least be in from the design side of things.
Yeah, I know. It's like I don't like that. It's like, oh well, we have to do hardware. It's like, no, want to do hardware. We want to do hardware. Hardware's cool. I don't know. And this whole economic side of this stuff is just...
It's
messy.
bullshit. Come on.
Yeah, it's bullshit. Right.
I know. We hate it.
Yeah.
Can we talk about something different?
Yeah, let's get on to something fun. How about the obfuscated C contest? Did you?
That's not fun either. That's stupid.
That's not fun. Oh, I think that's fun as hell.
No, who can come up with the most obfuscated, convoluted, unreadable line of code?
I think that's fun.
No.
Yeah.
It's fun for a bunch of penguin dwellers.
No
but,
way, man. It's firmware people too. I mean, come on.
No.
Some of our listening audience would like this, I think.
Oh, yeah.
In terms of programming languages, there's only one step further that you can get closer to the hardware. So I know that some of our listening audience would care.
No.
Now, if you ever do this and you hand me a piece of hardware that has obfuscated C on it, I'm going to punch you in the face.
Because it's not practical. That's what I hate about it.
Right.
And it's not even that fun because you read it and you go, oh, okay, I don't understand it. And, there's nothing fun about it for me.
See, now, okay, here's the thing. Here's why I think it's fun. Is because me and my friend at work used to do obfuscated circuit contests. And it becomes a puzzle, right? So, I mean, I get it from the C side of things. It's, like you and I are.
If you want to spend the time solving the bloody thing, yeah.
Right, exactly. And that's the idea. It's like it's a kind of an art form, and people enjoy trying to dig through it and figure it out, right?
Yeah, but and then you put dead end stuff in there, and you put,
exactly. You kind of, and they've done it on chips before too. They actually put in like fake parts of a. On an ASIC, they'll put in fake circuits, basically. They don't do anything. They do that same thing for when, people x-ray it and try and spend 6 months trying to figure out what it does. And it's, that doesn't do anything.
No, I just get... probably I'm a bit bitter because I just hate people who, these smart-ass programmers, right, who code it in the most... obscure. People actually do this in real programs, right? They use, instead of just making it all real simple with tons of comments and everything and making it real dumbass, no, they do the most convoluted way to do it just because they think and just because they can, right?
Right. It's like egos running into coding,
egos,
right?
Yeah, look at how good a programmer I am. So, look, I'm going to put this all on one line. Well, when you run it through the compiler, it's going to assemble the same way as if you did it on 5 lines. They're saving 4 text lines, but they're not gaining any speed or optimization. They're just making it less readable.
Right. Well, I don't think the obfuscated C contest is meant for production level runs.
But I find that very common in regular C code. I mean, probably, I'm a bit pissed off because I'm not very good. I can program in C, but I'm not, computer science trained level in C, right? I'm just a hardware hack C programmer, right?
Yeah. Oh, me too. I'm even less than that.
Exactly. Well, that's what most engineers, right? They've done a couple of classes on C, and they can get by, right?
Right, and you just get someone else's program and you kind of fiddle with it until it works.
And you get a program which is written by some computer science freaking, major or something.
Not in C, come on. You get a firmware guy who's really good with that stuff.
I know, but yeah, exactly. But, I get it all the time, right? I'll put my source code out there, right? And people will go, oh, this is shit. I'm going to rewrite the whole freaking thing because you've done it the wrong way. What?
Right.
It's readable. How have I done it the wrong way?
Right.
I mean... if granted, if you've got a reason to do it, like you have to optimize the speed or something, well, I would have put some effort into optimizing the speed of it, for example, or optimizing that loop out or something like that, and no, they just, no,
yeah.
I'm just, I get it all the time.
Let me ask you, have you ever seen this where people do this on purpose at work in order to for job security or something like that?
Oh yeah, absolutely.
Yeah. I've heard stories about that kind of thing. I've never seen it myself, but even on the circuit side of things, they'll put it in they'll put extra circuits or extra stuff on schematics. It's kind of the same thing with an ASIC, right? Yeah. They'll do that with on a schematic. They'll do that for a board, and they'll actually put in fake circuits there, and just for job security.
Yeah, not so much that sort of deliberate, but I know it's more common for people to deliberately not do good documentation. For example,
really?
Like their job is they're supposed to produce documentation, but they produce shit documentation, and that's the same as obfuscating your code, really.
Yeah,
or obfuscating your circuit,
it is, right?
Yeah, effectively.
Yeah.
Right? So, especially in big complex systems, right? If you don't have really good documentation, somebody coming in cannot understand it all, right? You could spend years trying to come up to speed on this thing.
Oh, yeah.
So
Yeah.
that's another way to do it. It doesn't have to be through the code or the schematic level or whatever. It's just sheer laziness or sloppiness in terms of documentation.
Yeah. Well, and I've even seen. I've heard of and I've seen a little bit of like people putting like fake signal names, or they'll put in like a coded, like coded signal name so that only they could then decode it, and they'll do like a find and replace. And man, that's messy, man. That's like, I mean, like, that's like internal industrial espionage, right? I mean, like,
yeah, exactly.
That's crazy. I don't know. Like, does that still happen? I would love to hear from our listening audience if they've seen that stuff still, because I've heard of it, but it seemed like it was kind of like a older days kind of thing, and and then I compare it to like like how you and I kind of know some of the open source hardware folks, and that's just the complete opposite of it, right? So it just kind of that computing in my brain, it doesn't make as much sense. Whereas maybe back in the day, like. It was a big thing, or maybe it was just a workplace thing, and engineering egos kind of was dependent on those, right? I'm not sure how to really process it, but
some people don't even deliberately do it as such.
Oh, yeah?
They're just got some some weird way of programming. They've just got they've got a weird way of doing VHDL. They've got a weird way of programming. They've got a weird way of laying out schematics. They've got, it's just non-conventional, really. And
we talked to this guy over on the Engineering Commons podcast about software, and he talked to a lot of scientists, and he was kind of teaching them how to code better and everything. And he mentioned he met a guy that had 20,000 lines of code on this one project.
Yeah.
And he's like trying to troubleshoot it and everything, and then eventually he finds out that the guy only used the top 5,000 lines of code. Yeah. Basically, when he didn't need it anymore, he would use that as his document revision. He would copy that out of the active part of his program, then put it below.
Right.
And some of it is just people not never having good programming practices. Like I mean myself, but that's a pretty extreme example too of like having 20,000 lines of code where 15,000 aren't used.
Mm. And that's one of the things that pisses me off. People will try and do it in one line, as fewer lines of code as possible.
Yeah, exactly.
It's whereas there's no advantage to doing that. Don't be terse. Be
be verbose.
Unless it's be verbose. Unless there's some real legitimate, hardcore requirement for you to have to do it, some other way.
Assume your follow-on will be an idiot, right? Assume your follow-on will be an analog hardware guy who has no idea what's going on.
Mm-hmm. just simple stuff like
nice.
assigning a variable. Do it on a separate line. People know they'll use the C, thing where you can assign the variable first and then, and no.
Yeah.
Jeez. Yes, you can do that. Yes, C allows it. Yes, but... does it make for readable code? No, I don't think so.
Yeah, just because you can doesn't mean you should. That kind of thing.
Yeah, exactly.
Right.
Yeah.
Right.
Urgh.
I've been running into all this stuff. I've actually been jumping back into I don't program that much. I mean, I'm mostly doing hardware stuff.
Yeah.
But I've been wanting to like exercise some hardware and just like simple spline kind of stuff. So I've been using the BeagleBone, and I've been trying to get that up and running, and I'm making a daughter board for that kind of thing.
Right.
And man, it has been a while.
Cobwebs, huh?
Yeah. Oh, so many. And it's like it's even just like I'm like, oh, I want to get up and running, and I want to make sure I know how to use this thing before I start before I even lay out a board for it, right? Because if I can't do it, then why would
exactly.
Why have a board come in and then be completely clueless with what it is? Like be clipping wires to it and wiring it over to something else.
But it doesn't work.
Yeah, exactly. Yeah. It's a lot more Linux based than I thought it was. I mean, like, I should have known all this stuff, but it's very, very Linux based. I mean, basically, it's running Angstrom. But
see, that means nothing to me.
Oh, that's a distribution of Linux, so it's kind of like Ubuntu, but it's modified for like smaller devices and everything. And I've been doing, on the bright side, I've been doing a little more Linux stuff when I've been fighting with our servers. So I have a little more knowledge about it, but it's,
I think if you have to go down to that level, you're doing it wrong.
See, now what would you do then? So, like, say you just want to.
I've never had to do anything Linux on my servers, and I've been operating my own servers for
you mean server
15
side? Okay.
years.
Okay, no,
Right?
I know what you mean. Okay, I thought you meant on the semiconductor side. So,
No, on the
So
server
if you're doing like a dev board though, how would you do this? Say you wanted to just try out a new SPI ADC, right?
Yep.
How would you go about exercising that? How would you actually? I mean, would you just
These days
build
I
it
might
and go?
Well, these days I might actually use use something like the Bus Pirate, for example.
Oh, okay.
Which you hook the wires up, and then you have a higher level, programming language effectively that you can send commands to it and get commands back, just like a ping.
So is that graphical then? I've seen your video, but I don't remember.
No, it's all text. No, it's all text based. So you send it. You type a text command into the
right.
serial command window.
That's right. Yeah, so like a hyperterminal or something. That's right.
It's
I did
like
see that.
serial hyperterminal thing.
Okay, so you would just send certain commands like that, and that's that's the same thing I want to do. Like basically the thing I like is I want to have a single platform where not only do I want to build a little board. I want to be able to have a laid out board, and then I want to be able to rip off chip number 1, put down chip number 2, hook up signals, send it to the fab, and have it back. Right, basically making like breakout boards that also happen to have SPI and a serial link, like just a simple link kind of stuff. And I guess that is Bus Pirate, but I don't want to do it on a breadboard. I can't wrap my head around doing a breadboard these days. Yeah,
same here. I groan if I have to sort of try and do it on a breadboard, and a lot of surface, a lot of it's going to be surface mount stuff too. 0.5 millimeter pitch. You can get breakout boards, but I don't keep those in stock. I've got to.
Right.
May as well. By the time I order that, I may as well order a board.
Right. And it's just kind of the new reality too, right? So I think about all the analog stuff I work on. Basically, I need to be able to talk to chips these days, right? That is just the new reality.
Yep.
That's why I started Chip Report TV. I wanted to. Basically, the idea is these days we're just chip integrators, right? that is the sad reality of it.
That's pretty much, yeah.
Yeah,
but it allows us to do so much more.
Exactly. I'm a one-man band, right?
Yep.
Well, once I figure out the BeagleBone, I will be. But that's the idea, right? You need some way to talk to a chip. You need some kind of development platform because, dip parts are just not realistic. People complain about that, but it's just, sorry, folks, it's just reality. We are in a QFP world, we have moved beyond the dip, unfortunately. And, I could go and I could buy, breakout boards from SparkFun, and they're good for that kind of stuff. Or, there's lots of options for that kind of thing. But then, even if I'm buying these chips, if I'm doing 20 megasamples, I'm not doing 20 megasamples on a friggin', breadboard because, those kind of, you'll start getting parasitics in there. I want to actually, worst case scenario, I'm doing copper clad, and best case scenario, I'm laying out a board and actually have a decent layout. And
exactly.
Yeah. And then you get all the back end stuff too. Like that's the other side of it is that, I'm developing with these chips, right? I need to not only, check if they work, right? I assume they work. That's not always a great assumption. That's not always a great thing, right? Assuming that a chip works, like errata sheets do exist. But on the same token, once if I actually exercise the chip by throwing commands at it, then I'm already halfway there when I'm on the firmware side. I can just hand over this code that does work.
Yep.
And I'm sure you've run into that with your USB power supply and everything else, right?
Tons of projects like that. Yeah, where, if I've got an existing project that uses a similar interface, like it might be an SPI or an I2C or something like that, a lot of the times I'll take that and I'll have my separate board with the new chip and I'll wire that into the old board because that's the platform that drives the... and I've already got some code that can drive that, and I extract all the other stuff I don't need and just leave, the code to drive the SPI bus or something.
Right.
And
that's really
scratch, and
Yep, that's smart. The only downside to that is that you end up usually, you'll see people who are like, oh, well, if you're using 8051, it's not a big deal, right? It's like, oh, well, that's still around. But you don't really ever, you just end up using the same thing in projects. Like, I'm sure you've seen that. If you use the same chip, you're like, oh, well, it works, right? But then, if you miss out on some of the newer stuff if you have like an ARM chip that already works, or the ARM chip that has new features, or like an FPGA or something like that. There's never really any incentive to move on to the next thing. So that's the only downside, really. But on the other hand, if it works, it works.
Yeah,
right?
That's fine. Yeah.
Yeah, get it up and running,
What's
get
the
it out the
problem?
door. Right. Just get it shipped. That's what's important.
But I agree. It's always a pain in the ass. That's why we've talked about this before, I'm sure, that a lot of the time it's just not worth prototyping and hacking something together to test. I just go straight to the production. Well, I have a first stab at a production PCB.
Right, exactly. You expect it might fail, right? You're
You expect to do a couple of revisions, but that's fine.
Right.
But at least I've got 95% of the guts of it there, and I can program it, and I can I don't.
Right.
It's just
and
it's
then
just
the
much
only time
easier
you run
to do.
into it is when you need a new digital platform, right? You know that you need to talk to it with a new processor because you need a new display. You want like a touch screen now instead of a like a serial kind of thing. So that's. Yeah, man.
Yeah,
That's,
I just jump straight in there and
that's smart.
lay out the board and get a bait. It's
right. You save a little money that way too, and you save time. Yeah,
possibly. Yeah, but I mean, often you get down the track, but usually you're going to get it 80 or 90% right. Mm-hmm. Usually
right. A couple cuts, couple
yeah,
jumps, right?
Yeah, exactly. You're going to have to you're going to have to change your board, but it's usually not going to be a complete rip up and relay out kind of thing, so that time, 80% of that time, 90% of that time you invested in doing that board, well, it pays off at the end because then your final layout is, 80, 90% done to begin with. Mm-hmm. And then your code's done because you haven't hacked code from here or there. It's all on the final platform you're going to be using, and I don't know. But each to their own. I do see a lot of people a lot of people prefer, I'm going to, go to, hell on earth to build up, to hack up this thing and try and get it working before I commit to my PCB. And, well, if that's what they want to do, fine.
Well, and I think you see that more with lower budget projects too, because you need to get it right? I mean, like, I've worked somewhere before where it's like there wasn't money to expect failure, right? It was like, no, you have one shot, you have to get it right, and that's the difference, right? I personally think that there's already there should be a budgeted failure in every project, right? I mean, you should expect at least one board turn, probably two, and you don't want to be sloppy about it, but engineers aren't going to be necessarily sloppy, and it's like I think you get a lot of if especially because then you have engineers who are willing to try stuff out, right? If you know that your first board turn is going to fail, right? It's not going to be the final revision unless it, like you have a 5% chance. Then you're willing to throw in other circuits on there that could end up being your quote unquote innovation, right? If you say from the beginning, oh no, you have to get this right, what are you going to do, right? I mean, you're going to put the exact same digital section, you're going to put all of the exact same stuff on there versus trying out something new and actually doing something cool, right? I mean, that's the downside to it all.
And often you're, the system you're working on is so big and complex, you can't just hack up little bits of it, I mean, you're going to go for that big final board, you've got the product you're designing is one big final board. The only choice you really have is to go for one big final board. You don't have time to dick around and and spend months and months developing all these little boards to test out all different various aspects. You're going to jump straight in there and and as I said, 80%, 90% of the time you're going to be there. So yes, you'll do a few revs, but at least you have something to show off at the design review meeting. Look, it's almost there. You know? Whereas if you show off just a little, a breadboard with a couple of link light, that doesn't impress anyone. Right?
No.
A breadboard. No. Oh, look, I managed to, you go into your design review meeting with all the managers and look, I built the breadboard and I'm able to talk to this chip and they go, well, who cares? It's not, they don't have anything to scratch and sniff.
Right. Exactly. Yeah. They want they want a feature, whereas you have a component working, right? And
exactly.
They want to see the pretty display, right? And that's like, wow, you get that in the last 10% of the project.
Yeah, exactly.
Or after you've already released and you actually are iterating on the stuff you can update in firmware. It's like, no, sorry, the getting that last ppm of error out of your design. No one gives a crap, right? Unless you can't sell it.
Yeah. Or they want the physical final form factor board to fit in the case, so that so that they have at least something to show off.
Right. That's a good that is a good lesson for young people. I'm learning that one. I've learned that over the past couple of years of the like the Yeah, the drawings of your product matter just as much as the actual, like CAD drawings of your product, right? The industrial designs can matter just as much.
And often the circuit doesn't matter at all.
Right,
Nobody
exactly.
cares. Management don't care what circuit you use to get this thing working. They only care about the final form factor, right? So it's important to get that quickly up front so that you can show some progress. Hey, look, we're on the right track, and people can play around with it. And
right. Oh yeah, I tweeted about that the other day. Just that people don't give a crap. They don't care. Like if you walk into a meeting with a range of different engineers, you walk into a meeting with a mechanical engineer, an industrial engineer, like a software engineer, and maybe one other EE, right? If you walk in and you say, "Oh, well, look at like how cool this A to D is," or "Look at how cool this display technology is," they're gonna look at you, they're gonna blink their eyes, and they're gonna say, well, does it work? I mean, like, does can I control it externally? Is it reliable? They don't give a crap how it works. They just want it to work. That is the basis of high level electronics. They don't care how it works. They just want it to work, and it sucks. It's nice when you have people that understand how it works. That's why you should cherish people that do understand the electronics, because because there's a lot more that don't give a crap. There's a reason that we are not we are never going to be a very popular podcast. I mean, we have a good chunk of people that do care how stuff works, but there's a lot more people that care about how the gadgets work, right? There's people that want to know how the phone works and what apps you can put on it more than what's inside the chip and how many transistors it has and like all the low current specs it has or whatever, right? I mean, like no one gives a crap about that. So,
and I've even for my own personal projects, right? I don't get a lot of satisfaction of breadboarding a chip up and talking to it. It's like, I mean, if you've seen
you get the accomplishment, right?
You get the accomplishment, but I know I can do that. It's like no big deal. I want that final form factor. I mean, if you've seen my USB power supply video, right? I hacked up a final board and just did it. I didn't, because I wanted something that I just can look at and go, look, I've got something real. I've actually shown what looks like almost a finished product, right? And I did that just bang. I didn't even think about it. I just, I was getting some boards made, so I lashed up a thing and I laid out a board and bang, I put it on the panel and, I ended up with that board. Sure, it's not the final one. I'm going to completely change it, but at least I ended up with something that I could scratch and sniff and play with and turn the knobs.
Get feedback on, right?
Exactly.
Yeah, show other people. That's
exactly.
also important.
And, whereas if I had a circuit on a breadboard, it's like, boring.
Yeah, that is...
That's even for my own personal project. So, I don't know, but everyone works different. I mean, some people do get, a big sense of, especially as a beginner, you get a big sense of satisfaction for building your chip up on a breadboard and your LED flashes and you finally talk to it. Great,
Oh, yeah, even before that, I mean, I remember some of my first boards, like when I got the boards made, I was just turning them over my hands nonstop. I couldn't it's just a good feeling, like getting that board in your hands. It's like, I made this, man. That's cool.
I know.
I like this. I know. I will stick with electronics. I shall continue. Yeah.
So that's an interesting question. With custom PCBs now being so cheap, the only reason not to do it is time. Really, it takes X amount of time to, X amount of a week or two to get your board, manufactured and sent to you. But there's no real major cost reason anymore, with the likes of the various low-cost PCB share services available.
Oh, yeah. So what do you mean by that, though? I mean, you mean...
Well,
is breadboarding is a way of the past?
Breadboarding, is it going the way of the...
I don't think so.
No, I don't think
it's good for beginners, right? I mean, that's why you do it, right? So you can actually see that connection. I mean, making that jump into PCBs is tough. It's a... Yeah,
true. But once you've done it, do you go back?
Once you've done it once, though, yeah.
I don't breadboard too much these days.
I mean, I'm doing most of my circuit designs at work, and...
where budget's not a problem.
Right. Well, not even that. It's just having a breadboard at work is just, I don't know. Like when you were at work, did you have breadboards around?
We did have breadboards, but we rarely used them. You know,
Right. I mean, it's just a matter of
incredibly rare. Well, because these things often you're working on are not breadboardable. End of
right.
story.
Exactly. Right.
You know, I mean, you have to lay out a board in order to plug it into a breadboard so you can access
Yeah.
it. Well, you may as well lay out your final board.
Right. No.
You know,
Yeah. Exactly.
I mean, no.
Or if you're having a service, you know, like sometimes you have people in your company that are doing layout for you. You know that can also
that's another
you know,
thing. You throw it over the wall and somebody else does it. And, you know,
exactly.
wipe your hands of it.
Yeah. Interesting story I saw this week on Electronics Weekly. So it's LEDs, so it's not necessarily relevant to all electronics, but Osram, the LED maker,
Yep.
they actually they made pads on their LEDs so that they could cross-reference against other LED manufacturers, and I love that idea.
Huh?
So basically they have or maybe it was they. No, they have standards. Sorry. So they basically gave away footprints so that you could second source their parts or competitor parts based on the difference in footprints, right? So you have, Osram makes one type of LED with a footprint, and then I don't know who else. Osram's who? Sylvania, that's Philips, right? Then Cree is the other one, right? Cree is another big one.
That's right.
So maybe Osram and Cree have different footprints, but they basically give you a footprint pattern that then you can put down so you can second source either one. And I love that idea.
That's pretty cool.
Yeah, exactly. They said they give you that footprint, and they've already done all the work for you. And basically, you just throw that down, and then you can put down either one. I think
Nice.
I think we need that on every type of part, especially for And they designed their packaging footprint too to be more generic, right? Because if you have real specific, like a little pin here, big pin there, right? It starts to really throw off,
Yep.
your design, or your crossability, right? But say even you were going from like a SOIC 8 to like an MSOP 8, right? I mean, like you could make a fancy footprint that could fit either one, and it's a little easier with LEDs because you only really need two pads. But
Right.
I'd love to see that kind of thing for higher pin count stuff. I always whenever vendors ask, oh, well, what kind of feedback do you have for us? Well, I want standard footprints. I want
Yeah,
you guys
exactly.
to stop being D-bags about, oh, well, this is our proprietary technology. No, I want to cross your part. Let your part play on price and let it play on how good it is.
On performance and,
Exactly.
everything else. Yeah.
Yeah, because it's only getting worse, right? I mean, we talked about a little bit
Yeah,
before
I know.
about not being able to, breadboard something. I mean, hell, you can't even put down a second part on a tiny package layout these days because, the footprints are all so different, especially with QFNs.
I find it every day when I'm laying out a board. I'll have to do a new footprint.
Oh,
right?
yeah.
Because
That's
it's
when it's
some
obvious.
manufacturers, weird ass, slightly different to, oh man.
Yeah. Now there's a reason to like dip parts because it's a little more likely they'll be. It's at least a standard, pin spacing. It might not be the same pin out, but it's at least the same.
Well, we already
pin
have
spacing.
enough standard, in terms of SO packages, and but there's so many variations of the, the small MSOP type.
Yeah,
How
yeah.
many variations are there in just an 8-pin, dual inline surface mount,
Yep.
package?
Yeah.
I mean, there's just so many.
Right.
Leadless, J-lead, and the leadless carriers, there's probably 3 different types there in the leadless ones, and oh man, no.
Yep. That's lame. It is really lame.
So I'm always laying out new footprints, always.
Yep.
It's a pain in the ass.
It is. It is.
Oh man.
I saw someone actually sent this in. Speaking of footprints, it's actually a pretty cool video of like an old Motorola IC. Not an IC. It's a module actually. They took old components basically, and they basically created a module with like 100 mil spaced headers, and then they actually sealed the whole damn thing up, and then it was a pluggable module in like old school TVs, like we're talking like tube style TVs, but they actually made modules for it. So it's a pretty cool
Nice.
video of seeing how that goes in there. I mean, good luck trying to find one, but still.
Right.
Yeah.
Oh,
I don't know.
it's all gunked up. I'm looking at the video now.
Yeah,
It's all gunked up in brown stuff. What's?
Yeah, it's like sealed, and it's I'm sure they were doing that was probably security back in the day too, right?
Right. Okay.
But Yeah, it's cool to see. I mean, like, so it's not a new concept to make proprietary modules and stuff like that. I'm sure people complained about it back then too, right? Except back in the day, you were complaining that it wasn't a standard tube instead of a standard footprint. But still, it's cool to see that stuff. I mean, back in the day, especially like the old TVs and stuff are cool, I think.
But if you tried to open them up, you just open them up and they're pretty depressing. Though they might be cool in some aspects, but they're just old and crusty.
Depressing, like
yeah, like they just smell horrible, and they
that old burning dust smell. You don't like that?
They're just they're just and let alone trying to desolder and resolder them. Have you ever tried to desolder old boards?
Yeah, get your 100-watt iron out, right? Because they got like a
and the smell.
Oh, the smell too. Oh, yeah.
They've got a unique old component smell to them.
100% leaded solder and broken dreams. Is that the smell?
Right. Oh, boy.
Yeah. Speaking of huge electronics, did you see Evil Mad Scientist? Did you see their post?
No? What have they done?
They went to a swap meet, and they found this old Bussmann fuse. It's a liquid power fuse, and it is just monstrous. So, people know about fuses, right? Fuses are boring, right? I mean, they're just basically tiny pieces of wire that if you put too much current through them, they blow up, right?
I'm looking at this. This is almost a work of art.
I know, right? It's crazy. It's like it looks like a baton. It's so big.
Yeah.
But the specs are even crazier. I mean, that's the really crazy thing, right? 23 kilovolts at 15 amps. You want to get your calculator back out and figure out how much power that is? That's like megawatts, right?
Oh, the thing I'm looking at, though, is it's one big coil inside. How much inductance does this thing have? It's basically an inductor.
Oh,
really.
Yeah, it looks like it, right?
In a tube. It looks like an inductor.
Yeah.
Wire wound, air-spaced inductor in a tube full of oil.
Right.
Like, holy
it's
crap.
Insane. Yeah. That's actually it's 350 kilowatts. That's how much power it can handle.
And what's this used for?
I have no idea.
Do they have a clue?
I'm guessing power. I mean, or arcing or something. I don't know. I didn't read. I was so amazed. But I think they have a whole post on it, but it's pretty cool. I think they didn't get a chance to pull it apart, but it is crazy. So people should check it out. I mean, yeah. I've been looking at
used on power poles and stuff by the looks of it, possibly.
Oh yeah.
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 Huge ass stuff. Big power engineering. Ugh, scares the crap out of me.
Yeah.
Anything over 12 volts DC, high voltage, as far as I'm concerned. Don't touch it. Yep. Yeah. I'm a low power, low voltage man. Always have been. Yep.
Yeah, I've never had that benefit of that.
Everyone asks me, when are you going to do Tesla videos? I have no interest in that sort of stuff. No.
Photonic induction, you're not going to follow on
No photonic induction. No, it scares the absolute crap out of me. I won't touch it. No.
Yeah.
I hate working on live 240 volt stuff. I refuse to do it anytime,
240 scares the crap out of me too.
Possible.
120, that just tingles. 240, that hurts.
Nah, no thanks.
Yeah. Well, speaking of Tesla, did you see this? It's been a couple weeks. This has actually already been going
Tesla
on for a while.
Museum.
Yeah. So there's a society basically that has been trying to get a museum going for a while. But the backstory is, if people haven't heard this, I'm never sure how much our listeners have followed the news like I do. It's tough to tell the difference. But basically, the Wardenclyffe, or how do you say it? Basically, his old Tesla's old workshop where he was going to transmit power into the ionosphere, then everybody could pull down free power from the ionosphere.
Which
never worked. Never worked.
Exactly.
Basically, it was a brownfield because it was a film factory for a while after they sold it off. The tower's gone, but basically they got it all cleaned up. It's for sale for $1.6 million. And basically, this foundation said if they get half the money, the state will kick in the other half, and then they can buy the property.
How did they get that? How did they
grant or something?
Yeah. How did they get the government to agree to?
I don't know. I'm guessing it's
going
probably
for the other half.
Unloading. It's probably unloading like a brownfield, right? I mean, I don't think I would want to hold on to a brownfield.
Man.
Yeah. So, it's the Tesla Science Center. Okay. But it's so basically the Oatmeal. If people have never seen, it's like these really snarky, awesome comics.
Yeah.
So
yeah.
Matt Inman, he got pulled in, I think by Reddit. I think it was by Reddit. But basically, he used his star power to, and he had written a comic basically extolling the virtues of Tesla over Edison and calling Edison a bitch and everything, which is a hilarious and true account of the differences between Tesla and Edison, and we can link that in. It's actually quite good. But basically, the whole idea was he was going to help with fundraising. And as of today, it was a 45-day campaign on Indiegogo, which is like a Kickstarter, but they allow charities. As of today, the 850,000 goal has been obliterated a while ago. We're 11 days in, and it's at $1.1 million.
So what happens there? The government, they don't get the government money?
No, they will. They'll still get the government money. Basically,
right.
any money over the 1.7 million for this campus will go towards actually building the museum.
Oh, and nice.
Yeah.
So the government will double it. So anything they get, the government will double it.
No. The government's only kicking at 850.
Oh, right. Okay.
Right. So they've raised 850 plus another 400,000 basically.
Right.
And oh man, my math is terrible today. Another 250,000. And basically all the other stuff is going to go toward, that was just for buying the land. Now they're going to actually be able to build buildings on it, make exhibits and set up
I possibly think they don't realize what they're getting themselves in for here. Because the government will want an organization, they'll want reports, they'll want...
No, they do. They have all that stuff. They have a 501(c)(3). Yeah, it's a legit company. It's a legit charity already. Yeah, so this is
right.
This is for real. I mean, this all existed before Matt Inman got to it, basically.
Right.
And but basically, people want to donate. You can, get. Basically, it's just like any other, Kickstarter campaign. You can get stuff for it. You can get a photo of Tesla, or you can get a bumper
T-shirt
sticker,
or a
T-shirt. Right. T-shirt sold out. You can get a baseball hat. But it's just a lot of fun stuff, right? I mean, but in the end, the cool thing is, this might get Dave to the East Coast finally. Right? I mean, if there's a Tesla museum, I'm sure you'd go to New York, right, Dave?
I'm not a huge Tesla man. No.
No? Oh.
No, it's not that exciting. I'm sorry. I'm not going to fly all the way to bloody New York just for
if you're out there
East
for
Coast, just for...
Make your fare in New York one year. I'm sure you'd go to
if I'm in the area, of course I would visit, yes. But, not going to go out there just for that.
Oh, just for that? No, I wouldn't expect that.
Right.
But, I don't know. I think it's cool. I think it's great. Yeah. I don't know. There's always people saying, oh, we shouldn't do this. Yeah, man, government, blah, blah, blah. It's okay, whatever. At the end of the day, it's going to, preserve a piece of historic property, and it's going to
I totally
be
agree.
a museum.
Cool.
So it's, plus Matt Inman's a funny guy. So I enjoy it. I enjoy it a lot. So that's the oatmeal.com, I think. Or is it the oatmeal? Whatever. We'll link it in.
Our time's up.
Is it?
It is.
Lost track.
It's
sad.
up.
Well,
Sorry.
people can find links that we didn't get to this week. That's a nice bonus there. And it's on a site that won't crash. At Reddit,
Because it's not managed by you.
Exactly. I am poison to all things internet. Reddit.com/r/theamphour. And we'll put a link in for that too. And then Twitter and Facebook and everything else.
Cool.
All right, man. We'll see you next week with mystery guest number 3.
We think.
Yeah. See you then.
Bye.